Welcome to Redbird Mathematics. In this video, we'll discuss key information to successfully launch Redbird Mathematics with your students. First, we'll provide a detailed overview of the Redbird Mathematics program, including the instructional model, program structure, adaptive motion engine, and initial entry points. Then we'll take a tour through the lens of a student, exploring the program's components, features, and supports, and going over some tips for success. Next, we'll explore some of the data reports available to you as a teacher in the Redbird Learning Center. And finally, we'll discuss additional resources that can help you facilitate a successful implementation with your students. That's a lot to get through, so feel free to pause, come back, and view as much or as often as you'd like. Now let's begin our overview of Redbird Mathematics with a little about its history. Redbird Mathematics was developed through an ongoing collaboration with Stanford University and represents the next generation of pioneering research in personalized learning. Led by Dr. Patrick Suppies, Stanford's Education Program for Gifted Youth, or EPGY, has delivered adaptive online courses to more than 1 million students over the last 20 years. An independent study from New York University found that Stanford's EPGY program had unprecedented student success. The study showed that the program was a powerful tool for personalized learning, not just for gifted kids, but for all learners. We'll talk more about how the adaptive motion engine helps each learner find his or her optimum learning level, but for now, let's take a closer look at Redbird Mathematics. Redbird Mathematics is a supplemental, web-based, adaptive math program. Since it's web-based, students can access the program in the classroom, at home, or anywhere they have an internet connection. It's also aligned to the Common Core state standards, focusing specifically on 100% of the major standards, or those that are critical to Algebra 1 readiness. And it addresses the Common Core criteria for focus, coherence, and rigor. Additionally, Redbird Mathematics uniquely combines rigorous math instruction with integrated STEM themes and digital project-based learning. Now that you know a little more about what Redbird Mathematics is, let's explore the instructional model on which it's based.
The Redbird Mathematics instructional model is a three-stage process designed to engage today's digital natives in their learning. At the first stage, students work to really understand the content using a variety of instructional modalities. This prepares them for the apply stage, where they demonstrate their understanding of mathematical concepts by completing practice items, contextualized problems, and games. At the highest level, we have the create stage, where students pull it all together to complete real-world digital STEM projects. Here, students use design, coding, or simulation tools, just like STEM professionals.
Now let's take a look at how this instructional model ties into the overall program structure.
Each grade of Redbird Mathematics consists of coherent units of skills that are critical for success in Algebra 1. Each unit begins with a video that introduces the STEM theme and mathematics for the unit. Then, students proceed to a brief assessment that determines their level of proficiency with the unit material. Depending on the results, students are either presented with instruction or taken directly to practice items. The lessons then consist of instructional material for understanding the content and item sets to apply what they've learned. Each unit ends with a STEM-themed multi-part challenge requiring synthesis of the unit's skills. Additionally, some units contain digital STEM projects.
Okay, so let's recap. Each unit consists of several lessons, and each lesson consists of instruction and item sets. Let's now take a look at how student experience through these units and lessons is personalized via the adaptive motion engine.
Redbird's adaptive motion engine that drives student progress is the result of decades of research at Stanford University. So let's take a look at the three key elements to adaptivity in Redbird Mathematics. First, instructional items are responsive to student input. Second, sets of instructional items expand or contract to meet students' need for more practice or acceleration. And third, the learning pathway changes between and within lessons depending on student performance. The simplest learning pathway is when a student is reviewing material they already know and answering each item correctly. The program recognizes the student as proficient and quickly moves them along to their zone of proximal development. So how does it look when students are in their zone of proximal development or need additional instruction? When a student is in their zone of proximal development, additional support unfolds. Each item provides deep instructional scaffolding. This scaffolding may be enough to keep the student moving forward, but if the student is answering items incorrectly, the item set will expand to provide more practice with similar problems. This may be enough to keep the student moving forward, but if the student is answering items incorrectly, they receive instruction. Students can review the instructional material at their own pace and return to the items when they complete the instruction. Now, this may be enough to keep them moving forward, but if they're still answering incorrectly, they receive additional instruction, which covers the same topic but in a different way. After they complete that instruction, they return back to the item sets. Now, this might be enough to keep them moving forward, but if they're still having difficulty, they may receive items from a precursor lesson. These items might also expand into a complete lesson, just like that initial lesson. Once the student completes the precursor items or lesson, the student is returned back to the initial on-level lesson. The precursors are informed by the Zimba wiring diagram and the learning progressions. This is the wiring diagram for part of Grade 4. You can see how the Grade 4 standards are connected not only to each other, but also to the precursor standards from prior grades.
So the adaptive motion engine is what keeps students moving along through the program, personalizing the experience for each student. But they do have to start somewhere. For each grade of Redbird Mathematics, there are 2 entry points, one at the beginning and the other around the middle. These entry points correspond to units that cover critical concepts at that grade level. Each student's initial placement in the program can be set in one of 2 ways. Students can either be manually placed into a grade of your choosing, or you may choose to utilize the course placement activity. This series of items determines what students already know in order to narrow in on their optimal learning zone, and places students at one of the entry points. Regardless of how a student is placed, the program will be just as adaptive, and as a teacher, you can always change a student's grade placement. More on that when we talk about the Redbird Learning Center. Alright, now that we've covered the basics, let's take a tour through the program as a student and examine some of its navigational features and instructional supports.
Upon logging in, students will see the unit intro screen for their first unit. This is the unit intro screen for the first unit of Grade 3, Understand Multiplication. The unit intro screen details the lessons and games contained within the unit. As students work through the unit, their progress is saved, and check marks appear next to completed lessons. At any time, to view where you are in the program, clicking the icon in the upper left corner will take you to the Unit Pathways screen. Here, students can see the units they've completed and the units that lie ahead. As students work through the content and complete each unit, more units are unlocked. Also available from the Unit Pathways screen are the multi-level games. These games are unlocked as students progress through the curriculum and can be played at any time. As you can see, I'm just getting started, so nothing is unlocked. Now, let's return to the unit and learn even more about the course. When starting a new unit, the first thing to do is to view the unit introduction video. This video establishes the STEM theme for the unit. At the end of the video, the student is given a description of the key math content for the unit. After viewing this unit introduction, it's time to start the unit. Each unit starts with a brief assessment called the Show What You Know. These items are based in the STEM context for the unit and are the first step in informing adaptivity within the program. In Show What You Know, students have the option of skipping items. If a student skips an item, the program will automatically place them into the instructional portion of the lesson. Once Show What You Know is completed, students will move into the first lesson. Because I skipped an item and also got an item incorrect, I've been placed into the instructional portion of the lesson. This instructional portion, corresponding to Understand in the instructional model, begins with an overview of the content students are about to learn. At the top of the screen, students will see indicators showing their progress through the instruction. Students can navigate back to prior screens at any time. Here, students will experience multiple types of instruction, including short videos, animations, digital manipulatives, guided practice, and direct instruction. It's important to remind students that it's okay to make mistakes during instruction. These items do not count towards final scores, correct percentages, or skill proficiency. Encourage them to take their time. Each instruction then concludes with a summary screen that details the key points students have learned. Encourage students to take screenshots of these screens for their math notebook. After completing the instruction, students then move into the Apply stage, a series of item sets. Here, students solve items to show whether they understand the content of the lesson. When students engage with the items, if they understand exactly what to do, they'll simply answer the question and move forward. But if they're not sure what to do, there are several built-in instructional supports for them. First, they can check the on-demand help. This pop-up explains the main idea from the lesson that is addressed in this item. If that's not enough, students can review the instruction again by clicking the control in the top corner of the screen. If an additional version of the instruction is available, which contains the same content and ideas but is presented in a different way, there will be two controls here. Students can review the instructional material at their own pace and return back to their previous location in the course by clicking the X. If they attempt to solve the problem and their first try is incorrect, they get a hint. This hint is based on the incorrect answers that they've selected and helps them understand how to move forward, correcting common errors and misconceptions. If their second try is incorrect, the correct answer is revealed, and the feedback suggests to students how to get that correct answer. The student will then receive more items that are similar to the first item, so they can practice until they become proficient. Students solve items and receive instruction to move through the rest of the lessons in the unit, and sometimes they unlock games that reinforce the concepts and provide additional skills practice. Each game begins with a quick orientation on how to play, and gameplay typically lasts 3 to 5 minutes. Let's take a look at Dino Dig. This game would be unlocked after students have learned about the array model of multiplication. Here, students need to make 2 regions with a total of 25 squares while capturing as many of the dino eggs as possible. As students progress through the course, additional multi-level games are unlocked. These games can be found on the Unit Pathways screen. Once unlocked, these leveled games can be played at any time. Let's look at Shelfie. In this game, students need to reach a target number using numerals and operations, a great way to reinforce number sense and operational fluency. Since success in the games is only as good as the learning that occurs before they are unlocked, it's crucial that students must first understand and apply the content as they work through the lessons.
Now that we know more about the understand and apply stages from the instructional model, let's explore the create stage by looking at one of the STEM projects, City Evacuation.
When the project is launched, students may view 2 videos. One introduces the topic and problem that students will explore in the project, and the other is an interview with a STEM professional in a related career. The introduction continues with screens that contain additional or background information and concludes with a statement of the project goals. Equipped with this introductory information, which can be revisited at any time, students are ready to proceed to the math tasks. During these math tasks, students first need to complete a task analysis, identifying the steps that they'll need to go through to be successful with the problem, giving them a framework for how they can work through the rest of the tasks. Next, students complete a series of tasks where they explore mathematical constraints for the problem and showcase their proficiency with the mathematics of the unit and beyond. To successfully complete these tasks, they'll need to reference and use various real-world information sources found in the sidebar. After completing the math tasks, students will use the digital tool to create and complete their solutions. Each tool launches with a recap of the goal, instructions, and additional constraints that need to be considered, and can be accessed again at any time by clicking the icon in the upper left. This is an example of a simulation tool. If students are not successful in their first attempt, they can revise their inputs based on the feedback presented. Some tools contain results tables detailing the student's last attempt or attempts, which further enables students to analyze and revise their inputs. Here is an example of a coding tool. In this project, students need to design a 30-minute exercise routine to burn a certain number of calories, while also meeting additional constraints. After running their code, students receive feedback and can use the data from the results table to revise and rerun their exercise program as needed to meet the goal. This is an example of a design tool. In this project, students build a satellite that meets data transmission and power requirements while remaining below a maximum weight. There are many examples of simulation, coding, and design tools throughout the program.
Now let's take a closer look at those all-important instructional supports, the helps, hints, and feedback. Let's review. Each lesson in Redbird Mathematics consists of instruction and item sets. From an item set, students can always revisit the instruction for the lesson as needed. Or they can click the blue question mark to open the Help pop-up. This is a short reteach that helps instruct on the concept of the item they're about to complete. If they get the item incorrect on their first attempt, they can click the red question mark to receive a hint to guide them in the right direction. And if they get the item incorrect on their second attempt, they'll get feedback that helps to explain how to correctly solve the item. Additionally, they can compare their last answer, which turns to red, to the correct answer, shown in yellow. Hints and feedback are also available in the instructional piece of a lesson. Working through the instruction is students' time to learn and understand, and learning from one's mistakes is a critical part of the learning process. Encourage your students to take time to read these instructional hints and feedback. The helps, though, are only present in item sets, where students practice and apply and are assessed on their responses. Condition students to check the help as their first recourse if they're having difficulty completing the problem. So what are some ways to optimize your Redbird mathematics experience? Let's look at a few tips for success.
First and foremost, encourage students to use the program resources. When you introduce the program in your classroom, be sure to demonstrate the on-demand instruction, helps, hints, and feedback that are built into each item, and engage them with the idea of unlocking and learning from games. Also, encourage them to set goals and work diligently towards those goals, all while staying as focused as possible. Ensure that students wear earphones to minimize disruptions, and have them use a math notebook to take notes and solve problems. Finally, encourage them to take their time as they work through the program. Learning is not a race, it is a process of understanding, applying, and creating.
When you are ready for your students to embark on their own Redbird mathematics experience, share with them your school's login information. If you do not have this information, contact your school administrator or your Redbird program manager. You will also need to know this login information to access Redbird Learning Center, the program's reporting system. To access individual student and whole class reports, log in to Redbird Learning Center with your teacher username and password. Click to explore your classes and choose the desired class from the list. This will take you to the Happening Now dashboard for your class. If your students are actively working in the program, this screen will display real-time notifications and alerts. These alerts are triggered when students complete a lesson, are accelerating through the curriculum, or struggling with certain concepts. You can use these automatically generated live alerts to intervene or congratulate students as you see fit. In the class roster on the left, indicators reveal whether each student is currently online, offline, or accelerating through the program. Note that these Happening Now alerts will not appear if none of your students are currently signed in. To access students' historical data, click Class Reports. From here, you can click to browse through the different reports available. Right now, we'll focus on the Class Details report. At the top of each report, click to expand the report help for a description of the metrics shown in the report. For example, current grade placement indicates students' current location within the program, allowing a quick glimpse into how they're progressing. Note that the current grade placement and other metrics may not appear until students complete the first item within the grade they've placed into. Click the arrows at the top of each column to sort the data by that column, and click a student's name from either the class roster or the report itself to open the student's individual reports. Be sure to scroll down to view all available data. Here you'll find a link to the student's current lesson, which is the same link available from the Class Details report view. Clicking this link will take you to the student's snapshot report. The snapshot report is a complete record of each student's unique pathway through Redbird mathematics. From here, you can see when instruction, additional instruction, precursor lessons, or items were received. Furthermore, each item is color-coded to show whether it was correct, incorrect, or skipped. You can also click any item or instruction to launch a replay of student activity. These replays display how students interacted with the content on the page, including keystrokes and the use of on-screen controls, and indicators show whether students answered correctly on their first or second attempt. Click through the tabs to view the different items in the set or screens of instruction, and use the controls to rewind or pause the replay if desired. Now that we've explored the types of reporting available in Redbird Learning Center, let's take a look at how you might use the reports to monitor student activity. Let's take a look at Jessica. She's in my 4th grade class, but her current grade placement indicates that she's only 7% of the way through kindergarten, or grade 0. That seems a bit off, because I know Jessica, and I know she should be working closer to the 4th grade level. So let's click the link to her current lesson and pull up her snapshot report. From here, we can see that she took the course placement activity and answered the first 2 items incorrectly, so she was placed at the beginning of kindergarten. We can also see that she skipped all 3 items in her first Show What You Know. If we dig a little deeper by viewing a replay of her course placement activity, it becomes clear that she wasn't really engaging with the program. She was just clicking through by typing ones. She also didn't view any of the helps or hints. So now might be a good time to step in and make sure that she's using the program as intended, to learn and progress. After completing the Show What You Know, it seems that she started to engage with the program. If she continues to engage and get items correct, the program's adaptivity will accelerate her and she'll eventually reach her learning zone. But since I've identified the issue and will talk with her about using the program, I'm going to go ahead and change her grade placement. To change a student's placement, simply locate his or her name in the class roster on the left, click the online indicator, and follow the prompts. Note that you can select from either of the 2 entry points for each grade, or you can choose to reassign the course placement activity. Please use caution when changing placement, as doing so will reset all previous student data that's been collected. We've now explored Redbird Mathematics and the Redbird Learning Center. Hopefully, you are getting a better feel for how the program will fit into your classroom routine. Before launching with your students, let's take a look at a few other resources available for successful implementation. Your Redbird welcome email contains all your necessary information to get both you and your students started with your Redbird experience. Additionally, if you have access to the Redbird Professional Learning Platform, or PLP, these references and resources may also be found in the toolbox for the Professional Development course Experience Redbird Mathematics. A final piece of advice before you get started with Redbird Mathematics. You'll want to ensure that your devices meet the minimum system requirements shown here. Note specifically that Internet Explorer versions 9 and 10 do not allow some features of the program to run properly. We highly recommend using Chrome. Regardless which browser is used, make sure the device is running the latest version of the browser, and also make sure that the device's operating system is up to date. Doing so before implementing Redbird Mathematics will help to ensure a more seamless experience for you and your students. If you have any questions as you begin implementation in your class, please reach out to your program manager, who can help you troubleshoot and provide assistance. We are excited for you to begin and look forward to hearing about your Redbird Mathematics experience.